All right, good afternoon, everybody. Welcome back to another live stream. Hope you all have had a good week. It is Friday, which is always nice, of course. I don't know if any of you Twitter users out there, but I follow this weird Twitter account that the only thing it does is every Friday at about 5:30 p.m. it posts this little clip of not Pierce Brosnan. Who's the new James Bond guy? Daniel Craig. Who he was on Saturday Night Live introducing the musical artist The Weeknd, and so all it is like a 10-second clip that it's just Daniel Craig saying, "Ladies and gentlemen, it's The Weeknd," and it's the best Twitter account ever because that's the only thing it does, and it gets me every single time. But anyway, so welcome back. Apologies that I've been away for a little bit. It's just been a crazy time for me with been busy with family stuff and work stuff. So we are back today, continue along with our computer vision project. So just to give a quick recap on what this is a project that I'm doing in tandem with my mentees from Normal Community West High School. So my employer, State Farm, they do a partnership with the high school for this program where if they complete all 4 years of these computer science courses, then, I guess I should say this is also in tandem with Heartland Community College, or community college here, that if they complete all these courses, then they will graduate from high school, not only with their high school diploma, but also with an associate's degree in computer science. So it's a really cool program. And right now, I've been with these guys since their freshman year. And so they are working on their capstone project. And as part of their capstone project, they are wanting to do this project where, because I guess their parking lot has some congestion issues at the end of the day, where they use computer vision to detect how long it takes cars to get out of a parking lot. That way, because I guess the students are inclined to say, if it's going to take me this long to get out of the parking lot, I might as well just hang in the school for a little bit and talk to my friends instead of just waiting in line forever. So transparently, I have talked to these guys. I'm not sure that this will actually manifest into anything, like in terms of like the school adopting this, just because there's so many like red tape around like using cameras and stuff. And I've talked to their teacher about that as well, but and the teacher's fine with that as long as the students are learning something. So this is equally a learning experience for me as well. I am not a computer vision expert by any means. I am a machine learning engineer, but I don't do a whole lot with computer vision. So I picked it up because it was a great opportunity to help out my high school mentees and additionally help out myself. So off here on the right, I have created a demo station because we're going to be using toy cars to demo the stuff. So actually, let me go ahead and show that to you. Just me with the demo station. Okay, so you can see over here, I actually have another webcam back here that you can't really see, but you can see my hand here. So the goal is that we can use these toy cars here, and this is these are two Tesla Model 3s. And then I don't know if it'll actually recognize this one, but this is like a Super Mario World car here. So yeah, in case you're wondering why the Model 3. So I got this for my birthday like 4 years ago because I've always wanted a Tesla. And so I joked with my wife that she should get me a Tesla at the time. And so about 4 years ago on my birthday, she did just that by getting me this. And then just last year, I finally did save up enough money to get my own Tesla. And so I got a blue Tesla. So this is actually my real car. This is what I drive. Fun car. So yeah, this is what we'll be testing stuff out with. So this is just like a regular, this camera that I'm pointing at right now. This is the one that we will be using for our computer vision stuff. We're not going to get overly far today because what the goal is they basically want to detect. We have like, let's say we got the white Tesla here. They want to know how long it's going to take this Tesla to move out of the frame into the parking lot. And right now, honestly, I don't have my camera set up the best. I need to get that set up a little bit better. But if the goal is, so basically track this car, see how long it takes to get out of the parking lot, and then maybe do some analysis on the side to see how long over time, like, because Fridays, for example, maybe it's not too bad to get out of the parking lot, but whereas Mondays might be, who knows? But that's what we're going to be focusing on today. So we're going to be covering just some basic principles of computer vision. Now, this is the third stream that we've done. So in the very first stream that we did, I talked about computer vision at a high level, at a conceptual level. So I will be touching on some computer vision things, but if you're wanting to know all the concepts about computer vision, I would urge you to go back and check that video out, since I won't be covering that here. And then I probably will be blogging about this because I do have my own blog, medium.com/DKHundley or medium.com DK? I don't know what it is, but actually, if you just go to dkhelmet.com, I have a link tree there that has links to everything of mine. So in terms of machine learning, usually the projects that we work on, we are training our own models. Given that this is just, we don't need like a specific algorithm that detects, Teslas, for example. We just need one that detects cars in general. And also given that, training a computer vision model requires the specialized hardware called GPUs, which can be expensive to use. There's no reason for us to train our own model. We can use a pre-trained model. And so actually in this stream today, I have found one pre-trained model that works, but it does a pretty poor job. So actually, if anybody out there watching this stream is more familiar with like more pre-trained models that are better for computer vision, hit me up, because I've actually struggled a lot to find like a good model that would work for this. So I do have one that works. It's just not great. So let's what time is it? Oh, by the way, so I don't know if I'll be doing streams the next 2 or 3 weeks. So on Monday, I am having a little bit of skin cancer removed on my mouth. And therefore, I'm going to have this unsightly bandage over my face. So if I do a stream, I'm going to do it with a mask on. But I don't know if I want to do a stream with a mask on. So we shall see. Oh, by the way, if anybody has any questions about this stream, so I'm dual live streaming at the same time on YouTube and LinkedIn. Both of those places have comment sections. Feel free to drop any comments. And and I'd be happy to answer them. And I need a haircut real bad. Okay, so, and got my drink, of course, today. Hope you all have your drink as well. Today's choice is Diet Pepsi. I'm kind of burnt out a little bit on Coke Zero, so I had to switch it up. All right, so let me go ahead and share my screen. And where is my screen share? Oop, there we go. Okay, so this is my desktop here, and we will go ahead over into here. And I've already had, this is my IDE. This is IntelliJ, IntelliJ Community Edition, in case those are wondering. There is a Pro Edition. I do use the Pro Edition for work, but I've not seen a merit in it for like just paying it for my personal usage. And you don't have to use IntelliJ. You can use VS Code or whatever. But so today, what we're going to cover specifically, as you can tell in the title of the live stream, is a Python library called CV2. And so the CV stands for computer vision. I don't know what this 2 stands for, honestly, because it's not like a version number. It's not like there was a CV1 per se. So I already have done the installation of all the Python libraries that I need for this. So I haven't done it yet. In fact, I'm going to make myself a little reminder here. I'm going to put a directory here. I like to create a directory called dependencies, and then I'm going to create an empty requirements.txt file. So I do intend on... Here, hold on just a second. Requirements.txt. So I do intend on making this repo a little bit more robust with a README and everything. So I'm going to add new file, README, and then it'll be very clear, like installation dependencies. Actually, I've done all of this work to date on my other laptop. So right now I'm using my Mac Mini here. But I actually did all this work so far on my my Microsoft Surface here. And there's 2 reasons I'm doing that. Number one is, my high school mentees are using a Windows machine, so I wanted to make sure that whatever I did worked on a Windows machine. And then the other thing that I actually really, I always thought this was kind of silly, but like this is actually awesome for computer vision. But if you notice, so this, like when I open this up, this is like the laptop here. But if you notice on the back, this Microsoft Surface actually has a camera, and that's been awesome for testing and stuff. So like, if I'm like upstairs, working at my kitchen table with my daughters, instead of having this full robust setup here in my basement like I have, then I could just use the rear camera on here, which has been amazing. I've actually this is my first Windows computer that I've owned in a really long time. I gotta be honest, I don't like the lower end Windows computers, but this Surface has been awesome. And part of the other reason I got it is I really wanted a laptop, a 2-in-1, a tablet laptop combo. And unfortunately, Apple doesn't make one, so I got rid of my iPad for that. Anyway, so this is our, that's my markdown, requirements.txt. So I did already install CV2 on my machine. Now, installation's a little bit interesting because it's not like you just do a pip install of CV2. So actually, let me see if I can Google really quick CV2 and see like what it recommends you download. Okay, so this is the OpenCV home page. Excuse me. All right, documentation. So here's the one unfortunate thing. Most some things like pandas or Terraform, they do really good at documentation. CV2's documentation is disappointing, to say the least. It is very difficult to read. Well, because you can see here, we just jumped into documentation, and all it did was just jump us into, what is unless you really know what the stuff is, which I don't, then, what does the stuff mean? And unfortunately, even if you do, a closer of a, if you do, a more direct Google, it doesn't get any better than this. Unfortunately, the computer... the documentation for CV2 is pretty bad. I guess but the one thing I should note is, because you might be wondering, why not just use some sort of alternative? And I don't know if there is an alternative, but I will say if there is, it doesn't matter because everybody uses CV2. So it is what it is. And so, okay, so this is the wiki. Oh, I don't think I've ever even seen this wiki before. But yeah, it's difficult to know what to install. The way I've known what to install is just by going out to other people's GitHubs to see what they've done. Oh, by the way, I do actually have my own GitHub that I'm storing all my work in. So if you would like to follow along, github.com/dkhundley. Come into here, go into my repos, and then this is the CV parking lot project here. So CV parking lot project, and you can see that I got some files in here. My commit message starting legit updates, LOL. Okay, so I will continue to update that over time for your all's benefit as well. Okay, so back to our file here. So what we are going to do, naturally, because we're going to be using this library called CV2, let me blow this up a little bit for you, is we are going to import CV2. Okay, so obviously we're going to be making use of this this computer vision library. And so the way that the computer vision works in terms of machine learning specifically is because this is all going to be done over video. And I've explained this before in other live streams, but I'll go ahead and explain it again here real quick. And that is you're not analyzing the video itself per se. You are actually analyzing the individual frame for a video. So I've used this example before. If you are a video gamer out there, you're going to know that, video gamers like to game at 60 frames per second as opposed to 30 frames per second because, 60 frames in a second. Well, even if you're not a video gamer, think about a flip book. If you've ever done one of those old school flip books, when you flip that thing, it looks like it is a moving image. And so that's actually what we're going to be doing here is we are going to be using a machine learning algorithm to analyze each individual frame. And although it is analyzing each individual frame, it's going to look seamless because it's going to be doing 30 frames a second or something like that. So the first thing that we need to do is we need to instantiate, hold on here, the source of our video capture device. So the way we do that, and so I like to use, I have a specific style. This is not exactly what you call, what's the word? What is this? Because there's MLA APA for writing papers. What is it called? PEP8. There we go. Instantiation. All right. So, but I don't. So this is not PEP8 kosher, if you will. This is just a personal touch that I like to do. So I like to break things down by using annotated comments for headers. So I'm going to call this script instantiation, and then I'm going to have another one down here called, all right, I'm going to call this my ongoing video capture stream. Okay, random side note before I keep going. So they are here in Bloomington, one of the popular internet providers is called MetroNet. And MetroNet's been running fiber optic lines throughout Bloomington for years now, and my neighborhood's the last to get MetroNet. And so they've been installing new fiber optic lines in my neighborhood, and I currently have Xfinity. And as they've been doing that, they have been severing our lines pretty frequently by accident, which means my Wi-Fi's been very unreliable. So if the stream cuts out, sincerest apologies. I actually just went on a drive to get my drink here earlier, and I didn't see anybody working out today, so I hope the stream doesn't get cut out. But if you wonder why the stream got cut out, it's because MetroNet once again severed my Xfinity line. Okay, so script instantiation. So the first thing that we want to do is we need to instantiate our video capture device. And so the way that we do that is I'm going to, and I'm a very heavy code annotator, instantiating the object for the video capture stream, because so one of the things instantiating the object. So one of the things that is in the CV2 is that it can reach into your computer and then know to like what camera to use. And so actually, by the way, if that's another reason I'm using my Surface for everything, and I try to avoid my Mac Mini for some of this stuff, is because I'm trying to do this whole project on what I'm calling commodity hardware. When I say commodity hardware, I mean just like your run-of-the-mill computer, like because I'm sure that we could create, or we could use some super fancy deep learning algorithm that would like do like perfect stuff for our car, like a Tesla might. But you know, I want this to be able to run on any computer, or any average computer. Like I'm okay with it not running on a Raspberry Pi, but like for like my high school guys, like I want this to be able to run on their computers just fine. So that's why I've also been doing my work on my Microsoft Surface. Okay, so the way we do this is we'll call this object video stream, and we are going to use the CV2 library here. And the way we instantiate this stuff is we call video capture. And then here's the part that gets a little bit weird is, so y'all might be familiar with index values is, so actually this is actually interesting. I did not know this until the other day. Because if you put like a number here, this is just going to grab one of your cameras. And so attached to my Mac Mini here, I actually have two cameras. I have this camera here that you are watching me on now, and I have the camera over there that is like the camera that we're using for my demo station over here. And I have not found a clean way to actually delineate which camera is which, opposed to using the index values. And that just comes back here. So actually, let's Google that, and I'll show you. Like this documentation, just it's so difficult to read. So like let's do CV2 video capture, CV2 video capture. CV2 video capture. All right, so this is the class reference, and so you can see here, like this documentation is so hard to read. Like when I look at here, like this, it doesn't tell me what to put in here. Like the only way I've been able to figure some of this stuff out is just by going out to see what other people did on GitHub and figured out like the actual documentation here is very unclear. But anyway, I think I'm doing a lot of talking and thinking at the same time. But anyway, one of the things I figured out the other day is, if you put an index value, it will grab one of your cameras. However, you can just pop in like a video clip. So like if you have like a .mp4 file or a .avi file, you could stick that in here and it would run through this also. So that's kind of cool. Like if you have like a recorded video that you'd like to run through. So yeah, so that is instantiating the video capture. And then we'll come back because we will want to import our model, our predictive model, our pre-trained predictive model, but we'll come back and we'll do that later. So the next thing that we need to do is we need to have this video stream always running. So if you all are familiar with for loops or while loops, we're actually going to be using a while loop here. And basically this is saying like, okay, because like I was saying, we're going to be analyzing this thing frame by frame. So basically we're going to have this loop running over and over and over and over and over and over until we stop it. So the way we're going to do that, and I'm going to make a comment here, continuing to iterate through the individual frames of the video capture until manually stopped. And actually, so with that, I'll show you how we actually manually stop that, and that's going to be done by pressing the Q key on your keyboard. And so I'm actually going to put printing a statement indicating the proper way to halt video capture manually. And so, by the way, I am a robust code annotator, if you will. You don't need all these comments, but this is just for you to, and also for me, just being honest, to keep track of our stuff. So what we need to do here is, I'm just going to print a statement here. So print starting video capture stream. To halt the stream, please press the, all right, and we got to do the escape key to get the quotes, Q key on your keyboard, like so. All right, so there we go. All right, I am just checking to see if anybody's asked any questions. No questions, so we'll continue along. Okay, so basically, as I was saying here, is we need to instantiate a for loop. So we're not white while true. And so the first thing that we need to do is, like I said, we need to get the frame of the video capture stream. And remember, we're going frame by frame by frame here. And so the first thing that we want to do is retrieving the individual frame from the video capture. Okay, so I'm going to be 100% honest, like in case you're wondering like how I'm going so fast through this. So like you'll see I'm operating in this file called test.py file. I actually did, like, because I've actually found that these streams go a lot more smoothly if I do a little bit of pre-work. So I actually did this work the other day. And so if you see here, there's a video detection.py file here. I'm basically retyping this all here. Like, I did write all this code, but, and so I have it on my bottom screen here, and that's why I'm able to do this so quickly. Just being totally honest and being totally transparent. Okay, so what we need to do here is we are going to be retrieving two values from this video stream object here. So again, remember that we instantiated our video stream up here. So the first is like, and again, this is where this documentation here is so confusing, and I still don't really fully understand what this is supposed to be doing. I've read through this documentation like 4 or 5 times. I still don't understand what it's doing, but it works, so I'm not going to argue too much with it. But basically, you have two different things that are coming out of this. So we're going to read the video stream.read as such, and then the two values that we're getting out of here are a return value, which I'm going to just call ret, and then the frame itself. So return value and ret, and basically, so you know, the frame makes sense. So this is the frame, the individual frame that of the video that is going on. The ret is, this is the way I understand it, is that this is like a Boolean indicator, basically saying, okay, like if this is going to be true if like this is working just fine. It's going to be false if the video stream is not working fine. And so to that end, we're actually going to have a thing here that says, you know, if this thing is not working right, then we are going to break the loop and stop the video. So halting a stream if something is technically or is not technically working. Okay, so the way we do that is if ret is false, capital F, or type of frame. So the type of this object here, excuse me, let me take a quick sip. The type of the frame here is none, is type none. Then what we want to do here is just break this loop. And what the loop is, breaking the loop does is just basically halting the stream. Okay, now, so if we want to actually display the video, what we need to do here is use CV2 here to actually display the stuff. So what we're going to do here is showing the current frame, showing the current frame with, I'm just going to call it showing the current frame. So we're going to use, again, CV2 here, .imShow, and I don't know what IM stands for necessarily. And so we're going to call this frame, and then frame. So actually I have not looked this up before, or maybe I did and I just don't remember. So CV2 IMShow. Okay, so IMShow method. Oh, that's Geeks for Geeks. Okay, Geeks for Geeks. So yeah, but basically, actually this is even, Geeks for Geeks has it better than their own documentation, but basically they're saying, okay, this is the name of the window, and then this is the name of the image. So actually, I'm gonna change the name of this. I'm gonna call this parking lot video. I'm gonna change that. In fact, I think I'm gonna change that over in my legit file. Well, actually, we'll see how this works. So this is basically just showing a video of this. And so technically speaking, given that the only thing that these guys are really concerned about is making sure that we can detect how long it takes a video to get, or a vehicle to get out of a parking lot, there's nothing that's really mandating us to actually have a video showing. It's just kind of a nice to have, if you will. So Now we're almost done, but the one thing, like, so actually, let me go ahead and try to run this right now, just to show you that this is actually not going to work, and I'll explain why it's not going to work here in a second. So this is it. So I'm going to cd into my container. Oops, cd container. Let's clear Python test.py, and looks like I have a little syntax error here. All right, so that matches. And what am I missing here? Oh, I have an extra paren right there. Whoops, my bad. Okay, so let me try that again. All right, and you can see that it is not. Is it not working, or is it working? It's acting like it's working, but it shouldn't. Where is the video? Yeah, it's not working. And the reason it's not working is because CV2 actually requires you. Here, let me clear this up. It requires you to have an exit key. So if you recall here above with our print message, here, let me collapse this. If you recall here above with our print message, we need to halt the stream with a Q key, and obviously we have not defined that anywhere in here, and so let's go ahead and find that. So setting the breaking key to halt the video capture when manually triggered. Boom. All right, so the way we do that is if CV2 wait key. So this is, and I think if I understand what this wait key function is doing, is it's basically looking at like what is the input that you're giving to your keyboard here. So here's my keyboard right here. So if I pressed the Q key when this was done, then it stopped. And the way we get that is by getting the integer value of the Q key, which we can use this ORD function to get. So this ORD function is basically taking the we want the Q key, but we want like the integer value of the Q key for the computer to understand. So then basically we're doing the same thing here. We break the loop. Okay, so now if I run this, so let's go ahead and try running this again. And like I said, I did all this testing on my other computer. Oh crap. Ugh, I don't know how much this is gonna work, folks. Oh shoot, I didn't even think about this. So unfortunately, I am running, because you can see here, I'm running on a Mac Mini that is one of the newer Mac Minis with the Apple Silicon architecture. And unfortunately, the architecture is more in line with this the ARM architecture as opposed to x86. And so and unfortunately, like, this is not the only thing that's happened. I've had problems with libraries like Cat Boost, not PyTorch, TensorFlow. Stuff isn't really updated yet to, at least in terms of deep learning and machine learning and stuff for these newer Macs. And it looks like this is not going to work for me because, oh wait, actually it is. or it is working. And okay, so I actually did, okay, so this is actually working, but I did have the wrong video selected, and this is where it can be frustrating. So if I come back here, let's change this because it was selecting the wrong webcam. So let me change this to 1 to see if this worked. I can't believe that actually did work, but I'm wondering if something else is not going to work. So okay, so here we go. Here, let me, click some stuff over here, and let me just show screen share with demo station. Okay, so this what you're seeing here in the top right corner is the raw video stream, if you will. Whereas opposed to like the stream or the video over in the left corner, I can't point to it. The left corner of the top left corner of your screen, that's the actual computer vision model that's running. And obviously it looks the same because we're not doing anything fancy yet, but you could see that, we're not doing anything fancy here yet. So let me go ahead and stop this. So what we want to do now is to load in our pre-trained model. And like I said, well, let me take this away from you real quick. Boom, so you can see better. You can see here over on the left side of the screen that underneath this models directory that I do have this XML file that is like a very basic detection model. And so the way that we are going to load this is that we're going to come back up here, and when we instantiate our script, we want to load the model. So what we're going to do here is we're going to be loading the vehicle detection model. Okay, and then so we're going to call this vehicle detection model, and then we're going to use CV2 here. So it's actually using this thing called CV2.cascade classifier, and then we are going to point to where that is in our our folder structure here. So models slash vehicle detection. Vehicle detection model.xml. So this works just. Now this is the part that I'm not sure is going to run well in my Mac menu, which I kind of forgot about this, so I should have tested this out before the stream. But so I actually don't know what Cascade classifier is. So let's go ahead and look that up together. So CV2 Cascade classifier. Okay. Cascade classifier. So in this tutorial, this is a tutorial. I don't want the tutorial. I want the class. Excuse me. All right. Cascade classifier is the Cascade classifier class for object detection. Oh yeah, because everybody understands what that means. Yeah, this is what I'm talking about. Like, this documentation could be way better. So I unfortunately I can't explain what this is doing. I would encourage you, if you really do want to understand this better, then you should check that out. Now, the one thing I will note is, let me show you in the terminal really quick that the file size of this model itself is actually really small. So cd models. Okay, so clear. Okay, so unfortunately, I don't think I can make this any bigger, can I? Yeah, I can't make my integrated terminal any bigger. Sorry about that, folks. Okay, so let's just do an ls-a. Or not ls-a, do a ls-lh. Okay, so you can see that this XML file here that we're loading in is only 116 kilobytes big, which is really small, which is why, that's why it's not performing that great. I think it's not performing that great is because, like, whatever is inside this XML file, it's not doing anything fancy per se. So that's why you'll see, well, if this does work, that this is not a great model. Okay, so let's go ahead and close this out. So we instantiated the object. So next, we need to actually make use of it down here. So I'm going to make a couple spaces down here. Now, when it comes to computer vision, and I've explained this before, in terms of conceptually speaking, like, how does computer vision work, and how does it know that a car is in detection? So all machine learning, all deep learning, all AI is basically fancy math under the hood. And so basically what we need to do is we need to translate real world information into numbers. That way we can do calculations on these numbers. And so the way it works with these, consider the screen that you're looking at, whether you're watching the stream on an iPhone, an iPad, or a laptop, anything. What your screen is, if you pull out a magnifying glass, you will see that the screen is made up of all these little individual things called pixels. And if you look really closely, here, let me see if I can just find a picture of pixels. Pixels zoomed in. All right. Okay, so here's a good example right here, off on the right over here. So this is like a grouping of pixels. So you can see, like, this is more or less what your screen looks like. So every single pixel is comprised of 3 color channels. So you have red, green, and blue. And basically, if you light these up in a different way, you can produce any color, or almost any color known to the human spectrum. Like, I know that, like, Apple will tout that, like, they're on a P6 color gamut or whatever. But anyway, so, like, let's say, for example, I just wanted a color purple. So, harken back to your preschool days. So how did we get the color purple? Well, the way we get the color purple is by we light up the red pixel all the way, we light up the blue pixel all the way, and we turn off the green one. And so that's how pixels work. And so the way the computer knows how to light these things up is each of these are represented by an integer color value. So basically numbers. And so then the way the computer vision works is we look at all of the numbers, and then we start to see what the patterns are amongst the numbers. And it's a very computationally complex kind of thing, which is why actually most people aren't aware of this. So a lot of these computer vision models or deep learning models use these things called neural networks. Neural networks, even though, like, they've grown in popularity in the last couple of years, like last 5 years or so, neural networks are not new. In fact, I got a good friend, Dr. Raj Ramesh. Dr. Raj, he has a PhD in AI. He works with me at State Farm, and he did, like, all the learning of, all the calculus and stuff that goes into these neural networks and stuff way back when he did his PhD. I don't want to guess Raj's age. like Raj is a great guy, but, like, basically, like, a long time ago, before I was born. I'll just say that, and I'm 32. So like neural networks are nothing new. The only reason that they've become more popular is because we were not able to ever actually enact a neural network because the computational power required for a neural network just didn't exist. And in the last 5 years, obviously, as computational power has gotten more and more it's gotten better and more widely available. Now these things are just now starting to catch on. So that is how computer vision kind of works from a conceptual level. And so when it comes to, so I guess, one thing to note here is that this can be very computationally complex. So the goal here is, can we minimize the computational complexity while still getting the value that we want out of the model? And so basically what I'm saying is can we find a pattern amongst the data without using all of the data per se? And so there are a couple ways that we can do this. So because like if you're watching this on an iPhone, for example, I think there's like something like, well, let me Google it real quick. I use an iPhone 12 Pro Max, max number of pixels. It'll tell me here real quick. Okay, so whatever 2778 times 1284 is, multiply those numbers together, that's how many pixels are on my iPhone. A lot. And so it can be really computationally complex to run throughout all of those pixels. So there are a couple things that we can do. Number one is we can lower the resolution. So basically we're taking the number of pixels and then scaling them down to where there's not that many of them. And the way the resolution kind of thing works is it'll just like group like things together, and so if you're ever watching YouTube on your iPhone, for example, and you're on cellular data, it might look might look jaggy and stuff because depending on your cellular network quality, you might not have a good cell signal, and thus they have to compress the video down some. And I apologize if you can hear that. Sounds like my daughter's crying upstairs. But okay, so yeah. Oh, and then the other way we can get around this too potentially is by turning all these pixels into grayscale images. So in that sense, instead of having 3 color channels, we just have the one grayscale image. And so that's actually what we're going to be doing here. So we've read in the frame, and then we are going to change this into a grayscale image. And so the way that we do that is so let's make a comment here, like I like to do, turning the frame into a grayscale image. And so again, in a perfect world, if we had ideal compute power, you would just give the machine everything. But we do these fancy tricks so that way we can run these computer vision models on hardware that is not as expensive or as computationally powerful as like a $10,000 computer or whatever. Okay, so we're going to turn this into a grayscale image. So we're going to call this grayscale frame equals. So the way we do that is using CV2 again. So we're going to do CVT color. So I'm pretty sure that stands for convert color. So we are going to pass the frame. So again, we've got the frame from the stream up here, and then we are going to turn it into a grayscale. So we're going to do CV2.color underscore BGR to gray. And I don't know what BGR stands for, but maybe background something to gray, but that's how you do it. So this is turning it into a grayscale image. Okay, and now we are ready to actually pass this frame into our predictive model. And so the way that we do that here, we are, let me put in here, so getting all detected vehicles from the frame with the vehicle detection model. And I spelled something wrong here. What did I spell wrong here? Vehicle. Okay. Okie doke. So I spelled detection wrong as well. Detection. All right, so getting all the detected vehicles. All right, so the way that we do that, I'm going to have all vehicles. So this is going to be like, what is the word? A list of the vehicles. So it's actually going to be like a list of XY coordinates. So, or not just XY coordinates, but also WH coordinates. So XY and then YH. And then we're going to draw bounding boxes around those here in a second. And we'll talk about what bounding boxes are. All right, so all vehicles equals, so we're taking our vehicle detection model. Let me copy that down here. And then we're going to do a detect multi-scale. I don't know what this actually does. I'm curious. detect or CV2 detect multi-scale. Oops, that's supposed to be one word, and I spelled multi-scale wrong. Well, let's see if it'll correct it for me. There we go. Okay, that's not what I wanted. Detect. I cannot spell today, apparently. Detect multi-scale. All right, so as you can see here, this is an overloaded member function provided for convenience. It differs from the above function. Okay, so what is the difference between these two functions? They look the exact same to me. Okay, whatever. This is an overloaded member function provided for convenience. It differs. Okay, so what is that? I don't like this documentation. Detects objects of different sizes in the input images, and then the detected objects are returned as a list of rectangles. So again, it is giving us basically the corners of the objects. That way we can draw a bounding box around the thing. So actually, when I mean bounding box, so let me pull over my little car here. So my little car is basically, we're going to have like a rectangle encircle it. So we're going to have the 4 points of the rectangle. So 1, 2, 3, and 4 to create a bounding box. So it's basically giving it the coordinates of the bounding box. So let's go back to our code here. We'll go back to the code. All right, so, first we need to pass in the grayscale frame. And then I don't remember what these other values do. I just arbitrarily found these values from somebody else's GitHub. Let me see if I can find out what these mean. Is it, okay, a scale factor and then minimum neighbors. Okay, I don't know what that necessarily means. Does it say? All right, so scale factor is parameter specifying how much of the image is reduced to image scale. Okay, so I guess that's what I was talking about a little bit in terms of like in order to minimize the computational complexity of this whole stuff, we do a scaling kind of thing. And then min neighbors parameter specifying how many neighbors each candidate rectangle should have to retain it. Parameter specifying how many neighbors each candidate rectangle should have to retain it. I've read that 2 times now, and I still don't really understand what that means. But whatever. So just to make this a little bit clearer, let's go ahead and because I actually, people don't like to do this because you can get by with doing this, but I like doing this here where, you know what? I lied. I'm not going to do that. Never mind. Forget what I just said. Okay, so this is basically getting all the vehicles that our computer vision model is detecting. And so then to actually draw the bounding boxes around it so then we can show them in the video frame here, we are going to draw the bounding boxes. So drawing a bounding box for around all detected vehicles. Not vehicles, vehicles. Okay, so like I said, we have this this all vehicles thing. So we need to get the coordinates out of here. So for x, y, w, h. So x and y being these representing all the 4 corners of the bounding box that is being gotten out of this object. So for all that in all vehicles, we need to draw the rectangle. And so then again, we keep using even though this is not great documentation, I do have to say this is a really handy library because look, we're doing everything here with just one Python library, so that's pretty efficient. I like that. So I do like that. So I don't want to poop on this too much. So rectangle, and instead of using the grayscale image, because we do want to draw it on the original frame, which we will be displaying. So we're going to pass in our frame, and then we are going to pass in the XY coordinates as one parameter, and then x, y, and then the next parameter we're going to pass in x plus w, and then y plus h there. Okay, then I think this is a scaling factor thing again, so 0, 255, 255 here, and then 2. So I just want to let's look real quick. So CV2 rectangle, because this is the one thing that I personally like to do is because you can get by with just putting these values in, but I actually do like to because you can put the name of the parameter there, and I think that's more descriptive. Okay, so yeah, so image, start point, end point, color, thickness. Okay, so that's what this is doing. This is drawing a whatever this color is here. So I want to draw a blue box. Let's draw a blue box instead. So let's do 0, 0, and then let's make this 255. So actually, let's see if I can, so let's do image equals frame. All right, and then the next one is going to be what? This was called start point and then end point. Start point equals, okay, end point equals, okay, color equals that, and then what is the last parameter here? What is this called? Color thickness. Okay, so we want it to be 2 pixels big, thickness. Okay, so this one was a little bit more straightforward, but thank you to Geeks for Geeks. Okay, so that is drawing the rectangle for every single frame, and then we show it, and this is basically it. So, like I said, I'm not sure this is going to work just because, I didn't test this out on my Mac Mini before, but let's try it out. So we're going to run Python test.py here. Oh, I'm in the wrong directory, that's why. CD container Python test.py. Okay. All right. Missing one. All right, image. Is it not image? Okay, maybe Geeks for Geeks might have something wrong here. Well, I'll tell you what. I'm gonna do. I'm just gonna grab this here and just copy it back over. So, okay. So sorry about that. Apparently something went wrong there. All right. Whatever. No big deal. All right. So let's run this again. All right. So our video stream has been captured. And okay, now, all right, now let me get some stuff out of the way here. Okay, so my demo station, screen share with demo station. Okay, so again, top right corner is the raw video stream, and then the top left corner is the actual running model. So you can see that we are now having this thing run properly, but you can see it is not detecting the vehicles properly. So you can see that I'm getting like 2 or 3 bounding boxes on my car here. You could even see it started to do the headlight there a little bit by itself. I think if I just stick my hand right here, it'll even detect my hand. So that's what I'm saying. It was good for practice here. Like, it's good to see that this thing is working because it is actually going through every single frame here, and it's detecting that there is something there. However, you can see it's wildly inaccurate, and we need more accuracy than this. This is unfortunately not acceptable. And granted, again, this file that I'm using here is only like how many kilobytes? Like, it's not even a megabyte. Like, because I think a legit deep learning model would be quite a bit bigger than this. But yeah, so we're on a good track though. So let's just do a quick review here, and then we'll go ahead and wrap up for the day. And then let me halt this. So while I have clicked on this window here, if I click the Q key on the keyboard, like so, boom, it has halted the program, and then everything's good to go. So I'm actually gonna delete this test.py file because it's basically the same as my original file here. So I'm gonna delete this. We just did this for demo purposes. Okay, and so what we did here, again, to reiterate, we instantiate the video capture here, boom. We load in our model. And then with a while loop, this thing is going to continue to go over and over and over and over and over through every single frame of the video capture until we press our Q key or something goes wrong. And then as this thing goes over and over, we are analyzing the individual frame of each model. In order to do a more computationally efficient detection of these things, we are doing a grayscale frame. So again, just want to highlight one thing here. When we started the video stream, you did not see a grayscale frame. And the reason you did not see that is because when we do this showing of the frame, we show the original frame. The only reason we turn it grayscale, and I could have just, just for fun, let's show that. I don't know if this is going to work super well, but we'll try it anyway. So frame to grayscale frame, let's try this out. I don't know if this is going to work super well. All right, so Python video detection.py. So I think we should see, yeah, okay, so here we go. If I were to have had this, then you could see that we do have a grayscale frame here. Now it's not showing the bounding boxes because the bounding boxes are being attached to the other thing, but you can see this is even a little bit blurrier than the top right image here, and that is because we're doing a little bit of scaling here as well. So you can see they're actually, even though in our first iteration you could not see that, and I think I need to shut this off. Hold on. Sorry about that. I had to shut that off because that was, I think, killing the stream a little bit. All right, so video detect, or parking lot detection, or for parking lot video stream. And I'm going to turn this back into the regular frame. So even though, again, we are just showing the colorized frame in the end, and we are just drawing the bounding boxes in the colorized frame, behind the scenes we are doing a grayscale image because we are doing the actual prediction, or running the computer vision inference against the grayscale frame. So even though you don't see it, it is there behind the scenes. And again, for the end goal of this project, and we're actually going to halt the stream here in a minute because we're at a good stopping point and I don't have anything else to really share for today. But the goal here is, we got my cars over here on the right. The goal here is to be able to track this car and basically see how long does it take to move. And so that is one part I have not figured out yet. I've actually been working with one of my high school guys. Shout out Raphael if you're watching. He found like this blog that was talking about centroid tracking. So if you're not familiar with what a centroid is, so if you consider like a rectangle like this, consider the center of that rectangle here, and basically he found some blog that was talking about like tracking the centroids of each of these bounding boxes like that you saw on the frame there. And so if we can track those centroids, then we could see how long it takes to move out of the frame like so, and then return back. Because I think what the guys and I talked about doing is I think it'd be too complex to try doing on an individual spot basis. I think we're gonna basically separate these things into quadrants and basically say, okay, if you are parked out in this quadrant, it'll take you X amount of time to get out of here. If you're parked over in this quadrant, it's gonna take you Y amount of time to get out of here. And I'm saying quadrant because quadrant's 4, but it's actually gonna be probably more like 6 or 7, like sections. Sections is probably a better word. But just imagine, so if you were in this section over here, it's going to take you X amount of time to get out. If you're in this section over here, it's going to take you this amount of time to get out. And I just don't have any more code to show for that today because that seems pretty complex to figure out. And so I'm going to need to do a little bit of homework on the side. But that is it for today. So that actually went a lot smoother when I prepare ahead of time. So I hope you're all okay with the fact that I wrote all this code beforehand and then just basically redid it all in front of you. I think it makes these streams go by a lot more quickly. Usually my streams go an hour and 15 minutes long. We're gonna wrap this one up under an hour. So yeah. I don't know if we'll do this project or continue with this project again next week, or I don't even know if we'll be here next week just because, like I said, I'm having a bit of skin cancer removed, so I don't know if I'm gonna be here, or not be here, but if I want to do a stream with this big old bandage on my face, so we'll see. So last stream a couple weeks ago we started our Wordle clone thing, so we might return to the Wordle clone. And there is one other project that I am exploring around sentiment analysis with natural language processing. And we might do that. So it just depends. It depends on what I feel like doing, or whatever you all want to see. So I guess we never really did finish. I mean, we got pretty close to finishing the movie ratings model. I guess there is one little bit there I could show it too. So lots of different ideas. So that's cool. I got a lot of stuff to share with y'all, and not enough time in my day to do that. So hope you all enjoyed the stream. I don't have anything else to share for now. So we'll cut it here. I hope you all have a good weekend, and I will see you in the next one.